Okay, I'm glad you signed up for an introductory compiler course. Welcome to Kronos. I saw Jasper's slides earlier, and they had a lot of pretty pictures, and I was really scared of going after him because mine is really technical and with a lot of text, so I'm glad I'm not going after Jasper. But let's get started. My name is Hai. I am a dev tech engineer at NVIDIA. I used to work on Google Stadia and Android XR, where I was the graphics tech lead. And this is a list of some of the projects I've contributed to in the open source. Currently, it's Slang and Spirit Reflect. Previously, I worked on DXC. So I just show up to Kronos to sell you on different shader compilers. This is the latest one. And here's our agenda for today. And I'm trying to make this a little bit quicker than I had planned in the interest of time. So let's jump right in. What is Slang? Slang is a high-level shading language that brings modern language features to real-time graphics and bridges it into AI. A few of the things that make Slang stand out are, one, it's the compiler is backwards compatible with existing GLSL and HLSL code. It has a built-in module system that's a part of its standard feature. Has automatic differentiation as a first-class language feature. Slang also supports generics and interfaces as a straightforward way to specialize code. Unfortunately, we won't have time to go over the last two today. And recently, an exploratory committee has been formed at, exploratory forum has been formed at Kronos to explore the governance of Slang. And the purposes of the exploratory committee loosely is to proposing to continue open source work with multi-company governance, build industry trust by ensuring that Slang is not NVIDIA only. I know that's a concern. Enhance responsiveness of the current technical or the current open source project. And one thing that we get asked a bit often, and I wanted to just reiterate, is that when it comes to languages and compilers in the ecosystem, in the Vulkan ecosystem, it's Slang and DXC, not Slang versus DXC. We have a really good working relationship with those folks, and we hope to continue to do so. Okay, so Slang runs pretty much everywhere. If you've got a computer with a modern architecture and a reasonable operating system, like Windows, Linux, or Mac, it'll run. And Slang can take GLSL, Slang, and HLSL to any of these targets here, which is a lot. So, and for Vulkan, which is what we're interested in today, Slang obviously takes us to Spear V. So here's an example of some folks that are using Slang. I'm sorry, I didn't realize my taskbar was on there. My apologies. I guess we'll just have to suffer through that. Okay. So this year so far, we've had two previous talks on Slang. We had the first one at Vulkanized, and then we had the second one at GDC. And when we decided to do this talk, we really wanted to provide like a substantial update. So we actually came up with a plan to do a lot of work on Slang, so we had something to tell you as opposed to coming up and trying to talk more about Slang from a marketing perspective. So what we did, sorry, 1 second here. Oh yeah, so right after GDC, we started looking into the issues that affected the users, and we created about 38 GitHub issues, 16 of which were high priority for making sure that we had a release around this time for SIGGRAPH. And the aim was to, we wanted to improve the on-ramping experience for existing code bases. We wanted to clarify the language usage between Slang and the existing shading languages. And really, we wanted to fix a lot of the crashy bits that happens with shader compilers before you get to them, so that you don't have to follow the GitHub issues. We've done it for you. So with that, let's look at the Slang shading language. So here's a few questions that we want to address briefly in this session. What does Slang syntax look like? What common language features does Slang support? How does one use Slang's module system? As a user of Slang as well, one of the things that I've ran into is that Slang does have a lot of typecasting rules that are slightly different from HLSL. We won't get into a lot of them because we would be here forever. But I will go through them and point them out as we're covering some of the shader example code just to make your life easier. I realize these slides are super packed, so I'm not expecting to cover every single point, but when you get a hold of these slides and you want to use as reference, it has information that is not quite in the documentation yet, so that's why they're jam-packed with information. So apologies for the wall of text. Okay, so the good news is that if you know HLSL, you already know Slang. The syntax is super, like almost identical to HLSL for pods, resource types, struct types, entry points. The thing that Slang, where Slang begins to, sorry. So these are the two basic, so here's a vertex and a pixel shader in Slang. And you can, as you can see, it supports, it's pretty close to, it's basically HLSL, right? The only thing that's different, the first thing that's different is the, if you notice, like, I don't know if I can use my cursor, but on the vertex shader, there is a var pos cs equals mul, that statement right there. So we do have automatic type deduction, or type inferencing, whatever terminology you would like on that. So that's the first of the differences between Slang and HLSL. The second is the shader stage attributes. They're not absolutely required, but they're recommended. It does help Slang during the compilation process. And the reign of the code looks pretty much the same as HLSL, including the SV semantics. So, and Slang supports both the VK binding and register syntax for resource binding declarations. And if you don't want to use either one of these, Slang also supports automatic assignment for the resource bindings, and you can get to them through reflection. But be warned, the assignment scheme is not the same as DXC or GL Slang, so don't assume that it is, because you might end up with some missing bindings. So if you're going to use automatic assignment, then get through the bindings through reflection, as opposed to just assuming that's in declaration order or something like that. So let's look at some areas where Slang actually begins to differ quite a bit from HLSL. The first one, such as functions, namespace, and enums. So for functions, functions are globally visible in Slang, both inside and outside of namespaces, which makes for declaration redundant. So, which means Slang doesn't support for declaration. If you attempt to do forward declaration, you will definitely get a compile error. Slang also supports the modern syntax for functions and parameters. If you prefer that, I think it's similar to Rust and a few other languages. After functions is namespaces. There's some minor differences from HLSL. Namespace members can be accessed through the dot notation. Again, you cannot, one thing that HLSL allows you to do that Slang doesn't do is you can define a function using the, you can define a function using the namespace : the function in the code. The Slang doesn't support that. You'll get a compile error. And then enums. Slang's enums are scoped by default, which means you have to have the, they're scoped by default if you have a enum name. So if you can see it in a couple lines of code at the bottom here. So if you are using, if you have a scoped enum, then you have to use the scope resolution pointer to get, or sorry, scope resolution operator to get to the enum. If you don't want to use the scope resolution, then you can use you can tag the enum with unscoped enum, then you can use it the way that you normally did. You might be thinking, wow, that's an pain because I have a lot of HLSL code that I'm going to have to go and edit this. Don't worry, we have a compiler flag that does that helps you with this. We'll get into it in just a minute. The next part where Slang begins to differ or differs from HLSL is the struct types. Slang has constructor types. You can use it to initialize variables. You can see in the example code up here. The other thing is that Slang member functions that modify member variables need to be tagged with mutating. Unfortunately, there is not a compiler flag for this, so you will have to modify code if you have member functions that modify member variables. Static functions also you can also use static functions, and they can be accessed both through the scope resolution pointer, sorry, keep on saying that. Scope resolution operator and the dot access operator. And Slang also supports properties. They're similar to C# and Swift properties. The set accessor for a property is implicitly mutating, so you don't have to tag it with the mutating attribute. The variable new value is implicitly defined for the set accessor. Unfortunately, I couldn't cram more code into the slide, so Slang also supports operator overloading, and there's a link to the documentation in our documentation where it talks about this. One noticeable difference is classes are not supported in GPU code, and by that I mean Slang also compiles for the GPU, and there's some future work to get that working on the CPU, but it is definitely not supported on the GPU. So if you attempt to use it on the GPU, you will get a compile error. Okay, so now we get to one of Slang's standout features, modules. So modules can be made up of more than one file. As you can see up here, I don't have an example of that, but if you wanted to implement your modules over 2 different files, it's possible. It doesn't necessarily they don't need to necessarily go into one file. Modules can be compiled separately into Slang IR, and you can easily import a module using just the import statement. Like in the 2 shaders here, you importing these 2 modules, PBR and ACES. And you can control the visibility of functions and structs in modules using these access modifiers, public, internal, and private. So by default, everything is internal. So if you want a struct or a function to be visible, it needs to be tagged with public. Okay, so let's look at an example of these two modules that we have here, PBR and ACES. Each of these can be compiled into a separate IR module using the Slang C command you can see over there. And once you have them compiled into their separate modules, you can then compile shaders that use them just by compiling the shaders as they are. And if the modules are in the current directory or if they are in the search path, the compiler will automatically pick them up without you having to do anything else. It's pretty straightforward. And one thing to note is that you do need the .slang dash module because that's how Slang finds it. If you don't have that, Slang will get really confused. Okay, so one of the main benefits of modules is that it reduces compile time, and compile time is really precious. So when you compile a module, all of these things happen only once for the compilation: the lexing, the parsing, preprocessing, AST building, code generation, etc. And in our own tests on this, we saw a 1.5 times speed up using modules versus monolithic. And we used this MDL example, Omni Surface Brush Metal. It has about 9,000 lines of code. We're working on speeding up even further, but for now, it's a 30% is a pretty good improvement. The other benefit is code organization. Modules allow you to break down code into different files, different components, however you want to organize them that makes sense to your project. And of course, they can span multiple files. There is a cheat, like a legacy behavior. If you just want to use modules and you don't want to compile them to IR, you can actually just leave them as a .slang file and then use the import statements, and Slang will find them. If it can't find a .slang dash module, the next thing it'll look for is it'll look for a .slang file. Okay, so let's move on to writing shaders in writing Slang shaders in Vulkan. So here's a list of Slang features for Vulkan. With Slang, you can compile Slang, GLSL, and HSL code to SPIR-V. The majority of the VK : attributes are supported. Most of the DXC flags are not supported. One of them is down there. The FVKU's DX layout is not there yet. It's coming soon. For buffer layouts, by default, Slang will use STD140 and STD430 for the layouts. But if you wanted to use scalar block layouts, you can use one of these flags. And this flag, the FVKU's entry point name, It's going to appear a lot in these slides. It's critical unless, and the reason is that if you don't use this flag, all your shader code, all your SPIR-V output will have the entry point main, which can get really annoying. And SPIR-V, inline SPIR-V assembly supported, and pointers for buffer device addresses is supported. For the things that aren't supported is, one is the, as I mentioned, is the DX layout, and but it's coming soon, and specialization constants aren't supported right now. Then the primary reason is that we just haven't had a lot of requests for specialization constants, but if you're using Slang and it's something that's important to you, let us know. Okay, so here's a list of all of the shading stages we support, which is pretty much everything, and these are the shader attribute tags in case you're wondering. Okay, so let's take a look at like a basic vertex and pixel shader that has been Slangified. It's pretty much HLSL. There's no, there's no difference. The only major difference is that, or sorry, one warning. Slang doesn't support the sampler keyword. So if your code uses sampler keyword, you need to convert to sampler state or alias sampler. Again, you can use the register directive to specify descriptor bindings. One thing about this is that you will get warnings when you do this because Slang really wants you to use VK : binding for SPIR-V, but it's just warnings, and you can disable the warning by telling the compiler to be quiet about this particular warning number. The binding number is correct. It doesn't affect the compilation code or compiled code. Okay, let's take a look at mesh shaders next. So mesh and amplification shaders are identical to HLSL. There's just one thing to point out here is that Slang correctly does this. When you apply a flat decoration to uint vertex variables, it actually does do this. There's a bug in DXE which prevents this, and I ran into this and it drove me crazy for a few weeks because I thought I was writing my code incorrectly. But it turns out to be a bug. I don't know how many people actually do this. It's useful if you want to pass an attribute from a mesh shader to a pixel shader and do all your lookups there. So, anyways, it works. Everybody's favorite, ray tracing shaders, right? So ray tracing shaders they're between HL and Slang. They're pretty much the same. The one caveat is because of Slang's casting rules, the functions dispatch raise index and dispatch raise dimensions, you need to swizzle to the two component and then cast, because Slang doesn't support casted truncation. So if you attempt to cast from any 3 component to a 2 component, you'll get a compiler error. For Vulkan, I think the move often is to compile everything to a library, and here's 3 forms of compile commands that you can use to get to a library. And yeah, I know there's many different ways to do this, and we're working on isolating it down to make it a little bit less confusing. Here's the thing: if you specify an entry point when you're compiling in library mode, it's going to try to look for that entry point. Make sure you don't do a dash entry if your intent is to compile to a library. Mauricio was talking to me the other day, and he really wanted me to tell you that when they started using Slang for Aurora, Slang was easy enough for them to grok and reliable enough that they actually never had to reach out to the Slang team for help. Aurora is a great example of ray tracing using Slang and path tracing using Slang if you want to take a look. The code is super easy to understand. I've stolen some functions out of there because they were better written than my own. Okay, compiling Slang. Don't worry, we're almost done. So if you're compiling with Slang, here's the first 2 lines there are generally what you probably want to do for Vulkan, and if you're coming from HSL, you want to use this FVK use entry point name because you probably want your original entry points if you're going to do reflection. So if you're compiling Slang shaders, you don't need to do if you're compiling Slang language shaders, you don't need to do a dash lang Slang or a dash emit SPIR-V directly. They're both defaults. Saves you some typing. So if you don't specify an entry point, Slang will look for these shader stage attributes, and it will try to detect them. So just be careful there. So when you're compiling to Slang, we recommend that in most cases for you to use the dash profile sphere v to make it easier. There are a bunch of GLSL underscore, some version number. They're a lot. They're a little bit confusing. So the dash profile sphere v is a lot more direct if you're going to Vulkan. And if you really need to get really specific, then Slang also supports the HSL style profiles. I won't read them to you. You can read them. There's a lot. We'd be here forever if I try to read it to you. Okay. So a couple of things when using Slang C. So there's a Slang preprocessor macro if you need to isolate Slang code from other shared code between different platforms. One thing that is very different is that Slang does not have a underscore sphere v underscore preprocessor macro. And I know a lot of people use this to detect whether they're compiling sphere v or Dixel. So the workaround for this is just add it yourself when you're from the command line, or if you're going through the API, then just add it as an option. There is a more advanced mechanism called target switch that lets you customize the code for each target. Unfortunately, it's a little bit too verbose for me to try to cram it in here, so I linked to the documentation. I also linked to this issue that discusses it, why there isn't a sphere v preprocessor macro. This next part, I'll just ask that you read it when you get the slides, because it's just word soup. And I read it to myself a few times last night, and it's just going to sound ridiculous if I try to read it for you. And it's a little bit confusing, but if you have, when you're using Slang and you have some questions about entry points, it might be covered in these bullets. Okay, so just some recap of compilation. If you're compiling for libraries, here's the myriad of Slang C commands that you can do. And if you're compiling to modules, it's pretty easy. You just do dash target sphere v and then dash o, whatever your module is, dot slang dash module. And again, this is how Slang searches for modules. It initially searches in the current directory and any additional paths for a dot slang module. Oh, sorry, I will correct that before I put these slides up. But if it doesn't find a dot slang dash module, it'll look for a dot slang. But sorry about that. And it's been impressed upon me that compile time is really precious, so modules really help that. Okay, so on-ramping from existing code bases. If you're on-ramping from GLSL, it's fairly straightforward. Just do dash lang GLSL. This pulls in some of the GLSL specific intrinsics, and it also sets the internal language mode to GLSL, so we know how to, we know that the source is GLSL and to do the appropriate thing. For buffer layouts, you probably don't have to do anything, because if you're going for STD 140 or STD 430, it's the default. But if you're wanting to use scalar block layout, then use either one of these flags. The VK one is just a alias for the other. So in theory, GLSL code should just compile, but we might have missed some corner cases. I've been staring at shader code for like 15 years plus, and even like last week I found a syntax that I've never seen before, but somebody used it and it works. So if you find any issues, please report them, and then we'll get them addressed. If you're coming from HLSL, there's a few more. So there's 2 slides of this, but only 2 slides of it. Sorry, it's not exhaustive. These are just things that I found in working with Slang that I hope will be helpful to you. The first one is the enum thing. Dash unscoped enums just turns all the enums to unscoped to begin with. So this means that you don't have to go in and modify all your enum usage. And it makes it a little bit easier to deal with porting code from HLSL. Again, we don't have a sphere v preprocessor macro, so just add it from the command line. Buffer layouts, if you're coming from HSL and you share, and your application / render shares it with DX, you're probably going to want to use scalar layout or eventually DX layout. So just remember to modify the layouts. We also support a per object layout attribute. I don't know if there's a lot of cases for that, but it's possible to do. We don't support pragma matrix yet. There's a ticket filed for it, so hopefully it's coming soon. When you're porting from HLSL code to Slang, you will probably have to go in and add some explicit casting because Slang, like as I mentioned, Slang's casting rules are a little bit more strict. I don't have to cover the first point because apparently it got done right after I started these slides. So we now support one-dimensional matrices. I don't know if people actually use that, but I found it in a bunch of test cases. So the one thing that might get you is how in and out parameter, how in and in-out parameters or parameter declarations are handled in Slang. Slang really respects the constantness of the out parameter or the out decorator. So I've linked to an issue here that you can see some short discussions on why Slang chose to do something like this. If you have some feedback, please reopen that issue or file a new issue. So the matrix variants of select and or are not currently supported. The vector variants are, but we're working on adding the remainder of that. We don't support inheritance. Now, if you put some syntax in there, it will compile sometimes. But if you attempt to use it, the functionality is considered to be undefined. This one's a little comical. Unsigned int is supported. It has to do with the way that we lex and parse things. Most shader code uses uint anyway, so hopefully that isn't too big of an issue. And again, forward declaration is not supported. So if you do use forward declaration, it will require some code modifications. And that's it. But in closing, we wanted to say Slang is still forging ahead as well. We wanted to make sure that that you know that our development philosophy is to ensure that all technical work happens in the open, all language discussion happens in the open, and we want to make it possible for users and contributors to help shape the language and the compiler. And for the remainder of the year, and I'm sure the years to come, we want to keep improving support for the targets we do support and adding targets that make sense to users. And also we want to add new language and compiler features that are relevant to the Slang user base. So if you have anything that you feel like is missing from Slang, please file an issue. And just a reminder that the Slang does have an exploratory forum in Kronos, and the discussions on that will continue to happen. I'm sure Neil will update us when there's progress. And we would love any contributions from you at our GitHub repo. So if you got any bug reports, questions, or pull requests, just feel free to come on by. And I was going to do questions, but I don't think we have time. Okay. Now it's time for pretty pictures.